Thanks the organizer for inviting me here, and it's a good time to interact all my colleagues here because we are from the same fraternity. I have been working for pipeline since last almost 24 years. After leaving fertilizer, I was there for IFCO for near about 10 years and later on for 24 years only with the pipeline industry. Now during this stay with GAIL, Gas Authority of India Limited, when I worked mainly for HBJ pipeline majority of the time, and then for short period and near about 4 years in KG Basin, I thought we should share some sort of experiences when we really work on the field. Now, pipeline integrity is really a area or the topic of the day. Everybody would like to talk on the pipeline integrity. Since you may be knowing, a lot of accident has been taking place in India and abroad, and a lot of casualty during these accidents. Integrity, pipeline integrity particularly, is a very vast area. Corrosion is one of the things, and you cannot cover all the things altogether. So naturally one has to address segment by segment. So I tried to cover as much as possible, so time which may be required a little bit more, but we can later on have a discussion on any of the topic which you like to discuss. And secondly, whatever the knowledge I have, limited knowledge, would like to share with you. So this topic which has been given to me is about the importance of the corrosion control in pipeline integrity. Say if you talk over world over, it basically depends that how much energy the country is consuming. If you see the India's condition with respect to other countries all over the world, you will find that India is consuming only the 4.7% of the total energy what has been being consumed in all over the world. So we are at 4th place or the 5th place, but maximum of the energy is being consumed in USA, that is near about the 17%, then China 22%, and accordingly the number of the pipelines, the length of the pipeline is more in those countries because ultimately they are handling the hydrocarbons or transporting the hydrocarbon. Then here how the things are changing in India. Say in world over, the gas consumption is near about 24% of the total energy share. In India it is 8%. However, as far as the oil is concerned, it is not much of the difference. World over it is near 33%, in India it is 29%. So there it is being compensated with the help of the coal. So in India the coal use is more compared to other countries, but other countries are not using coal considering the pollution problem and the quality of the coal also. So here when all over the world when oil and gas is contributing near about 60%, in India it is near about 24%. So 37%. So there is a scope to improve from 37% to 60%, and accordingly handling that hydrocarbon product, accordingly more of the pipelines, and accordingly the requirement for the pipeline integrity. So I have taken some data from the website. This is the length of the pipeline which other countries are handling, particularly their top 4-5. Say in US, the pipeline which are handling the petroleum product is 8 lakhs kilometer. When I talk about the 50,000 kilometer in India, it is 8 lakhs there. When you consider the total pipeline in US, it is more than 18 lakhs kilometer. But this is considering all the pipeline. But petroleum it is near about 8 lakhs kilometer. Russia it is 2.5 lakhs. China, Canada it is 1 lakh. Then China 80, and then India is normally at 4th, 5th location. Now in India, if you see the total pipeline which is being operated as on date is near about 50,000 kilometer. And they are roughly, it is not very accurately, it is roughly. So maximum pipeline earlier being operated and maintained was initially by IOCL. They were operating near about 11,000 kilometer. But later on, a lot of pipeline has been added by the GAIL. So the maximum pipeline which is being operated as on date today is 13,000 kilometer by GAIL. This includes the gas pipeline, this includes the LPG pipeline also, 2,000 kilometer LPG pipeline also. And then you have the ONGC and GSPC, HPCL and all that. So total, when I say the CGD, which is basically 2000 kilometer, we are considering only the pipeline which is the steel pipeline. Otherwise, if you consider the MDP pipeline which is normally handled, then you can say it itself is near about 50,000 kilometer. Because in Delhi itself, the Indraprasth Gas Limited is operating near about 10,000 kilometer total pipeline. Out of 10,000 kilometer, less than 1,000 kilometers is the steel pipeline. And then maybe some other this pipeline which are basically transporting either water pipeline or maybe iron pipeline. There are many other pipelines that has not been considered here. It is only the oil and gas pipeline. This is just to show you the map. Now when we talk about the why the people use the pipeline is basically the safest mode of transportation. You might have seen a lot of tankers carrying the petroleum product, whether it's diesel, petrol, naphtha and all these things. So a lot of accidents are taking place. It is an economic mode of for the large distance, maybe for not less than 50 kilometer, but more than 50 kilometer is definitely the economical mode. It enhances the efficiency also. Latest least contact with the population, minimum hazard, and the pilferage is less. Though there is a pilferage in crude product pipeline also, the other product pipeline also, diesel and petrol, but in gas it is less because gas is being transported at higher pressure. So everywhere you will find the pressure which is normally more than 40-50 bars. So I mean really pilferage at that pressure, it is really difficult. And when you are handling the crude pipeline or the product pipeline, the moment some drill is taking place, the pressure come down. So automatically, I mean, people easily steal the material. But gas, it is not that easy. Most environment friendly, then reliable and regular supply is also there. Reduced load congestion, road congestion, ability to traverse most difficult terrain. Otherwise, when you are going to hill area and all that, then it is very difficult for to transport the product with the help of the through the road transport. Say there are some sort of accident which has taken place. I have just highlighted only 2 and 3, but in India itself, in last 3-4 years, many accidents taking place. About the one of the pipeline which is blast has taken place on September 9, 2010, where 8 people died. That was in Brunei. So this it was one of the main accident. Just 2014, near about 6-7 months back, there was an explosion in the Taiwan pipeline, and this was I understand the propane pipeline which was buried just below the main road, and that accident has taken place. There also 25 people died. In India itself, just a few months back, on the Gale pipeline in KG Basin, this accident has taken place where 21 people died and 18 injured. In addition to this, you might have heard the accident which has taken place in Jaipur. There was some accident at Hazira. So number of accidents has been taking place. So a lot of awareness is now coming. Earlier the people not taking very seriously. Now slowly there a lot of seriousness is coming about the pipeline damages, incidents, explosion which are taking place. And a lot of pressure from the ministry also that we try to keep it minimum, or we adopt all the safe practices so that the accidents should not take place. Now what is the pipeline integrity? So there are different definition in different codes, in different dictionaries, but basically ASME, they have clearly mentioned this, that the pipeline integrity is nothing but the ability of the pipeline to contain the product in required circumstances, whatever the pressure, whatever the terrain of the pipeline, whatever the profile of the land, but product should go in the safe way. That is the requirement of the integrity. Now why pipeline integrity is required? It is basically fitness for purpose or extending the life of the pipeline. You might have seen the pipeline in India which has been replaced within 80 years. I have seen that pipeline. In Gujarat itself it is taking place. And they are the pipeline in India which is operating for near about 50 years. In US they are the pipeline which is operating more than 70 years. So it is depending upon how you maintain the pipeline. Same pipeline can have a life of more than 50 years, same pipeline can be replaced within 5 years. And nowadays the cost of the pipeline laying is really very costly. For the large diameter pipeline, when you talk, it is about about 4 crores per kilometer. When you talk about the maybe gas pipeline of diameter 32 inch, 36 inch, 42 inch, 48 inch, the cost is very high. When you talk about the lower diameter like 8 inch diameter or the 12 inch diameter, maybe 1 crore, 1.5 crore and all that. So cost is really very high. So naturally, in case you can increase the life of the pipeline, the return is very good. Otherwise, it's very costly. Then accounting of for accuracy and the level confidence. Third is to detect the damage or the defect before they cause the serious problem. I mean, keep on monitoring. Ultimately, it should not lead that accident has taken place and only then you take the remedial measure. To ensure the pipeline do not become the defective or damaged or inoperative. And fourth is to determine the extent of the pipeline placement or the repair work to ensure the safe and efficient working of the pipeline. These are the requirements for the pipeline integrity. Now, the pipeline failure, there may be 100 type of the failure, but ASME carried out a lot of exercises and all that. They have tried to divide that what can be the reasons of the failure in major some sort of a groups. So here, if you find that corrosion is one of the major one. How you divide that is your choice, but if you see the corrosion is playing the major role, so 22% of the pipeline are failing because of the corrosion failure. There may be some third party damage, there may be because of the design, there may be a material failure also, but corrosion is also playing the major role. Now, when I protect the pipeline against the corrosion, there are the two ways through which I can protect my pipeline against the corrosion. That is the passive protection and another is the active protection. Now, passive protection is nothing but providing the coating. Providing coating of the pipeline is basically known as the passive protection, and through which earlier pipeline which are being laid in India or in other countries also, it was mainly the coal tar coating, where the asphalt coating, coal tar coating and all that, that was the coating available that time, and right now also it is supposed to be the cheapest coating. But slowly as the other type of coating has been developed, then people switch over to the other coatings. And then one very popular coating particularly used in US and the Canada side, that was the FB coating. Earlier they were using the single layer FB coating, but later on slowly people switch over to the dual layer fusion bonding epoxy coating. And in India, we have normally gone for the 3-layer P coating. Now, when we came, why in India 3-layer P coating, particularly in India, and you will find the Europe also, and maybe in Arab countries, the people normally go for 3-layer P coating. In Canada and US normally go for the epoxy coating. Now, epoxy coating thickness is normally they try to maintain near about 500 microns. So, road condition in those countries, road condition in India is entirely different. And then you have the pipeline, coating plant, maybe say 500 kilometer away from the place where you have to lay the pipeline. So road condition is bad. In that case, what is happening? A lot of damage on the coating is taking place. So once you go for the 3-layer P coating, you have the advantage of the epoxy. You have the outer layer, which is basically the polythene pipeline coating, and that is very thick, almost 2 millimeter. So even during the transportation, the coatings are not being damaged. So that's why majority of these countries, particularly Asian countries, are using this type of thing. But however, in Europe and Canada and US, normally the people use the epoxy, this FB coating. In active protection, you have again two types. Either you go for the impulse current CP system or you go for the sacrificial CP system. You go for the sacrificial when you will find that the length of the pipeline is very less, or maybe you go for the basically combination of the impulse current system as well as the sacrificial system whenever the requirement is there. Sometimes it is a hot spot where you are not able to really meet the requirement by ICCP only, then you additionally provide the sacrificial system. So combination of both is also maybe the solution. Case to case it is different. And in India and other countries also, normally when you lay the new pipeline, during just after the construction, you go for the temporary cathodic protection. So there you use the sacrificial system. So when you go for the permanent one, it takes some time, it requires designing, arranging the power source and all that. So during that 1 year, to avoid the corrosion, you normally go for the temporary cathode production, and that is being used where you go for the sacrificial system. Now a reliable power supply for the cathode production system is very, very important. You might have seen a lot of places, though we talk about that, okay, in India things are improving, but in rural area, if you go to the power supply availability is less than 12 hours. So once my total system is working only on the grid and power availability is not there, though 50% time your CP is not working. Though a lot of people say there is a, battery bank is also there, but you will find battery bank after maybe 1 year or 2 years is really not working. Some people say that, okay, generator will also be started. So during my life, I have almost carrying out audit of lot of cross-country pipeline from the OSD side. So on paper, everything is good. So people will say that, okay, the power failure has taken place, my generator will start, either it automatically will start or some person will be there. You will really, when you go there, you will find the power is not there, and the person who was supposed to start the generator, he is also not available. And sometime he is available, but he is not having the diesel or petrol, whatever is required for this one. So these type of problems are come. So naturally, you need a reliable power, not only for cathode production system, but you also need for the communication also, because nowadays communication is also very, very important along the pipeline. OFC cables are also there. So for that purpose, it is really required. And once the pipeline has been buried, there is nothing in your hand to improve the pipeline life. The coating is already there, you cannot replace every year, or it is not easy. Even if replace, many times you damage more the pipeline compared to increase the life of the pipeline. So it is only the cathode production which can enhance the life of your pipeline. And in case the cathode production 50% time the power is not available, so naturally it is not working. So naturally a lot of corrosion is taking place. So here the reliable power supply, which in lot of the pipeline you find either it is CCVT, that is closed cycle CCVT, or the solar system, or you go for the TEG. So TEG is basically again by GAIL they have used for our GREP pipeline, which is basically starting from Delhi to from Vijaypur to Delhi. This 36-inch pipeline, and then CCVT we have used on HBJ pipeline. Then solar also has been used a lot of new pipeline. So as a standby, the battery bank is also there, but everywhere the limitation is there. So whenever you are choosing the type of power source, it is important the cost is not the criteria. Because every time the people try to calculate what is going to be the cost, because the grid power supply is supposed to be the cheapest. But once it is not available and the pipeline life is reduced from 50 years to say maybe 10 years or 15 years, so naturally you can consider what is going to be the effect ultimately in the long run. So reliability of the power sources very, very important. Now when I talk about the integrity of the pipeline, there are a lot of threads. There are basically 21 threads. And the 22nd thread which ASAB mentioned is basically not known. You are leaving the things on the God. But on they try to categorize these threads, and these threads are basically in the three categories, which is time bound, the stable, and time independent. So when you talk about the time dependent, it is basically increasing as the time is passing. So it is mainly the corrosion, whether it is external corrosion or the internal corrosion or the stress corrosion cracking. And stable type defects are basically which are basically either in the material, okay, they are basically the plate through which you are making the pipe and all that. That type of defect which remain with the pipeline. And time independent is basically nothing is related with the time. Say like third party damage, incorrect operation and all that. This may happen tomorrow itself. This may happen after 20 years also. So it is not related with the time. So in three main categories, these threats has been classified, and you have to address almost all the threats and section by section, depending upon what is going to be the population density in that segment. The more the population density and that threats exist in that section, you have to give the importance to that particular section. Now here if you see the time dependent threats, the external corrosion is one, when the coating may be damaged, or internal corrosion. Internal corrosion can be because of the product which you are handling. It may not be totally dry. The quality of the product you are handling. So there is a chances that there will be a internal corrosion. Stress corrosion is also there. Now the pipeline integrity assessment method. As per the ASME, there are basically three methods. One is inline inspection, another is hydro testing, and third is direct assessment. When I talk about the internal inline inspection, is basically intelligent pigging. And now lot of tools, modern tools with higher accuracies are available in the market, but this can only be done when your pipeline is piggable. Because a lot of pipeline which are the old pipeline or a small length of the pipeline, there may not be a pig launcher, there may not be a pig receiver, maybe a lot of tapping on the pipeline. So once a lot of tapping is there, so there is always risk that your pig may not move at all the locations. So you normally go for hydro testing. Now hydro testing, though it is mentioned, but it is not easily, it cannot be done. For the pipeline, particularly the gas pipeline, like HVJ pipeline, other pipeline, these pipelines has not been stopped even for a single second since last 20 years. So how it is possible that you excavate the pipe, you take out all the gas and then fill with the water and then do the hydro testing. So hydro testing may be possible in some sort of a product pipeline, crude pipeline, but there is a lot of limitation because arranging so much water, again excavating that sort of a water, where to put it and all that is really challenging. So for the new pipeline and all that, it is easy, but for operating pipeline, hydro testing is not feasible. So in that case, you normally go for the direct assessment. This is very well recognized that you go direct assessment of the health of the pipeline. And there, as per SME, a lot of criteria has been, a lot of surveys has been, a lot of testing has been mentioned. Accordingly, you go ahead. When you carry out the internal inspection of the pipeline, so your quality of the result of the internal inspection will depend upon how clean your pipeline is. So everything from the inside of the pipeline should be taken out. And to make it sure that your pipeline is really piggable, there is no obstruction, the walls are totally open or not, you normally start with the foam pig, then you go for the gauge pigging, then you go for the brush pig. Brush pig is nothing but just to clean the internal surface of the pipe so that all the corrosive material is removed from the inner side of the pipe. Then magnetic pig you go. Here by basic purpose is that all the magnetic material which remain inside even during construction, like welding rods and all that, should come out. Then EGP, that during the laying itself you will find, I have seen a lot of the pipeline, once you put the pipeline without any cushion below this, it is like on the rock or in the brick and all that, there is a dent which is taking place on the pipe because of the weight of the pipe itself. So this can only be detected before charging the pipeline with the help of the EGP. So you can repair and again put into the use. The inline inspection tool and the ADD, the axial tool, is again to check both the type of whether the defect is on circumferential or axial side, that tool can be used. Now it is just to show you what is a foam pig, how to work. This is a foam pig. The advantage of foam pig, in case there is an obstruction on your pipeline, this can be broken. The moment you increase the pressure on your pipe, this can basically collapse, and then ultimately there is no disturbance to your flow. Just to make it sure that your pipe is piggable. Then you go for the gauge plate. It's again aluminum plates. In case there is something wrong, what can be done? It can come out, it can get bent and all that. So again your flow is not disturbed. So this is on our pipeline which carried out. Then third is basically brush pick, just to clean the total pipeline from inside. Then here if you see the one photograph, after the brush pick, lot of material is also coming along with the pick. Then you use the magnet pick just to carry out all the ferrous material. Now here if you see this pipe which was used in since last maybe 10 years, 15 years after operation, the first time when you carry out the cleaning through the magnet pick, all the welding rods come out. During a construction, a lot of material is being left in the pipeline, though it is tested and people say that I have cleaned 10 times, 20 times, 50 times, but even then the material remains. So once you carry it out until it being, all the things come. So it improves the efficiency of the pipeline also. Now these are the gravels, again pipelines. The pipeline may be in operation for 10 years, but all the things are inside. So this can come out. And EGP just to detect the dent on your pipeline. just operations. Now there are two type of the tools available in the market. One is basically when you launch the inline inspection tool, the whatever the defect which is circumferentially there is a crack and all that, that can be detected by CDP tool. Now when you go, the axial tool is there, there is a defect on the horizontal side, axial side, then that will not be detected. So there is another tool, the ADD tool. So that tool can detect both the type of the defects. So normally now the requirement is that there is a sort of a combo tool which has both the provision, and when you have the philosophy which is basically ultimately you are putting the magnet is saturating the steel plate, and then whatever once the thickness of the pipe is reduced, so there is a jumping over the flux that is being sensed by the sensors and all that, and based on that the voltage is generated. So you have the combination of both the tool. So all the type of defect, whether it is basically circumferential or it is axial, both can be detected once you have use the combo tool or use both the tool at one by one. Once you are not able to carry out the inline pigging to check the integrity of the pipeline, then you can go for the direct assessment. So here there are the different type of surveys. One is external corrosion direct assessment. When you carry out lot of things, mainly it is a cathode protection. So you go for the on potential survey, you go the off potential survey, you go for the continuous potential logging survey, you go for the coating test, you go for the CAT survey, you go for the DCVG survey, all that can be done. And for internal, you have the different time, either you carry out the measurement, what is the rate of the corrosion your pipeline is going on, what is basically the content, the corrosive material which is basically inside along your product. So there can be a lot of moisture, the water available, sulfur available, CO2 available with your product, which may be causing the internal corrosion. So accordingly you take the action. And then third is basically the stress corrosion cracking, which is normally happen when your potential is high and the temperature of the product is also high. So this happen normally once the just after your compressor station or booster station. This sort of phenomenon has not been observed in Indian condition, but normally it has been observed more in Canada and US pipeline. A lot of pipeline has failed because of this reason. Now how you carried out the direct assessment, normally the coating condition, you see the visual, then coating disbondment, you also check it through the peel off test, inspection of the pipeline, survey of the external corrosion, magnetic particle MPI testing you carried out, and sometimes you use the LRUT also, thickness measurement. And these are the surveys normally we carried out along the pipeline. Is again make the part of direct assessment survey. It is cleaning, CPL, DCVG, intelligent peeling, inspection of the SCC, and the coating peel off test. This peel off test can really tell you from the outside. You may be thinking the pipeline coating is good. Pipeline coating is good, but the corrosion may be taking place below the coating. So once you carry out the peel test, only then you'll find out that between the material and the coating, the corrosion is taking place. At a lot of places we have found this. So this is really required. And for this you carried out the bell hole survey on few of the pipeline we have also carried out. In case the bonding is not good, the bonding between the steel and the coating is not good, such type of problem take place, and there may be hundreds of the region. Sometime when you are applying the coating, you are finding the pipe temperature is not properly maintained, which should be maybe 80 degrees centigrade or 70 degrees centigrade now. Sometimes it is not properly washed. Sometimes anchoring is not really good. So there may be 100 type of difficulty, but mainly based on the input, you try to improve the system. These are the, as I was talking about, third party is very, very important. Third party damage take place along the pipeline. Now because I am looking after this CGD network in Delhi, I am finding third party damage is very, very high. And here because there is no ROU separately, it is only the permission to lay the pipeline along the road. Same along the road you have the electric cables, you have the telephone cables, you have the water pipeline, you have the sewage pipeline and all that. Lot of work is going on, lot of development is taking place. So third party damage is taking place. However, on the cross country pipeline also, In the same ROE, you will find a lot of people are digging the borewell, maybe carrying out some sort of other modifications. So that is also causing a problem on your pipeline. So naturally, the surveillance is very, very important. So some people carry out the helicopter patrolling. The inspection of SVs is also very important. Just few days back, you had a accident on the RIL pipeline. You might have seen the newspaper and all that. That was again on the SV station. The main cause is still to be investigated, but again, we understand basically the pipe which is going to the actuator from the wall. From that, the leak has taken place and a fire has taken place. So a lot of inspection is really, really important. At what frequency the individual company has to take the decision. The inspection of the roll raid crossings, this is again very important, because this is the area where a lot of damage take place, because a lot of renovation is taking place, road widening is taking place, maybe wash out because of the during the flood and all that is taking place. The only one of the advantage of carrying out the helicopter patrolling is that during the monsoon, it is not approachable that you go along the ROU. So you can really monitor the pipeline from some sort of a height which is near about more than 200 feet height. So during the monsoon also, particularly the excavation which take place, but the erosion on the pipeline which take place, the pipeline get exposed and is already known to the people. In case somebody want to damage your pipeline, it will be very easily can be done. So the helicopter patrolling, that only gives the advantage, though it is very costly, but it is very effective. Now the pipeline interference is now a very nowadays very challenging thing. Particularly in India also, you will find that once a lot of pipelines are being laid. Now one company has laid the pipeline in some ROU. Now addition to that, another ROU is not easily available. So the government will ask you that to lay the pipeline on the same ROU. This has happened in a lot of cases. And you will find on the same ROU, you have the old pipeline, then you lay the new pipeline. The interference takes place. Sometimes the one pipeline is coated like coal tar coating, another pipeline is coated with the 3-layer P coating. Again, because current requirement is different and both have the independent CP system, again the interference is taking place. Now lot of high tension DC pipeline overhead transmission lines are laid, because from one state carrying out the electric power to another state, you normally go for the DC transmission. Again is taking place. So what is happening that normally there you have a basically bipolar type of thing, that you have the two wire through which the current is going and then return path is provided. But many times it is not working. So what you use the earth as a return path. Now through the return path you will find a lot of current being picked up by the pipeline, and then once it is getting discharged from the pipeline, the corrosion is taking place. So this has taken place many times, in particular in the BPCL pipeline. At 1 or 2 times it has failed because of this reason. So you have to really take care of all the things and try to remove all these interferences. So common ROU problem is really now increasing in India. So one party is once laying the pipeline, another party is laying the pipeline after few years. They have to really negotiate, they have to come to the conclusion that what sort of a methodology I should adopt it, what should be the gap or what should be the difference between the two pipeline, whether we should can have a common anode bed, whether we can have a common CP or not, whether we can have a bonding or not, when we are crossing, what should be the space should be left, should be maintained between these two pipelines. So standards are available, but only thing is people once working independently, then both parties are losing. So now slowly that sort of a cooperation is really required. And and it can be a combination of all. You have this in the same ROU, different type pipeline, then your HVAC is also passing, HVDC is also passing, maybe some telluric effect on your pipeline can also be there, DC traction is also a problem. So this we have to address one by one, and they depend upon the pipeline to pipeline, location to location. So this is again one diagram just to showing when the one pipeline is passing to the another pipeline, and you have to provide the bonding, then you have to, people just normally bond without any resistance. So you have to really consider that, okay, what is my coating, what is the coating of the another company's pipeline. So accordingly you have to adjust the current requirement and take the decision. This is, I just explained how HVDC work. Now here the mitigation plan for when your HVDC or HVAC is basically passing on. Particularly for HVDC, you normally go for the anode with the diode, so that basically whatever the discharge is taking place for the pipeline is through the conductive path. It is not through the soil. So once the current is passing from the pipe to ground is going through the electrolyte, then only corrosion will take place. Once you are just draining with the help of the solid wire, then corrosion will not take place. So it is nothing but the same philosophy has been followed when you go for the anode with the diode. The bonding, if the earth electrode is close by, then additional CP rectifier with automatic controls. Then strategic electrical isolation, when you find the pipeline length is more, you want to divide some section is affected by the that's HVAC or HVDC, you can isolate and then go for the electrical isolation or combination of all the things that depend upon case to case. This is again some diagram just to show it. Now the telluric effect, though it is not very common in India, particularly Europe and those countries which are closer to the North Pole, particularly say the Germany, Denmark, Sweden, and Norway, there it has been found very common there. But in India also we have found on some sections on our pipeline, and then there what is happening, there's once there is some sort of a disturbance on the sun, now it is causing the disturbance on the magnetic field on the earth, and because pipeline work as a conductor, so in the same dynamo principle the power generated or the voltage generated on your pipeline. So whatever the CPU you are providing your pipeline, it based on this it keep on changing. So sometimes disturbance in the morning is more, in the lunchtime it is less, in the evening it is just gone away, in the morning again it will happen. So some sort of a trend if you see, you can really very well come to know that this is an effect, not by some other interference, but this is a telluric effect. And there are some study which we have carried out here on HVJ pipeline, particularly at one segment, if you see the GREV pipeline, I have just highlighted near to this Khudar. There is a segment of near about 150 kilometers. We found that some sort of a telluric effect phenomena is there. We try to analyze it, but when you see the how the trend is taking place, see this the graph. Now there I have chosen basically 3 CPU stations, maybe installed near about 20 kilometers away. Now you will find the different colors. The trend of the pattern, which is basically you will find on day-to-day basis, it is basically on the same pattern is flowing. See in the morning, the potential is going into the negative direction. Just after evening, it is going into the negative direction, and then it is varying in the evening. The next day, it will happen in the same way. In case that effect is coming in the morning maybe 9 o'clock to 1 o'clock, it will be same day. Today also, tomorrow also, next day also, and then for few months it will be there. Then slowly it may go away. Because this is not happening that disturbance on the sun will be on daily basis and it will be all continuously at the same magnitude. It may keep on changing. But normally once it's there for some time, it may go away. So this we have find out on that section. So here again what you will find basically nothing can be done much, because it is not a, first thing, it is not, lot of magnitude variation is not there. It is sometime you will find that you can manage by maintaining the settings of the rectifier in such a way, once it is going more in the negative side, you try to go in the positive side. Sometimes it is going on positive side, you try to keep your potential on the more negative side, so that it can be band, whatever the band you want to keep of the CPU on your pipeline, say 0.85 to 1.2. In case it is going on the higher side, so you try to bring that band lower side, so that during the disturbance it comes into the range. Sometimes what you go is you try to insulate that section. So you go for the isolating joint of particular section, maybe 50 kilometer, 100 kilometer, and try to isolate with the rest of the pipeline. Sometimes you go for the grounding side. So these are the some phenomena, but permanently nothing can be done on this, because it keep on changing, and this is also variation. Season to season. Sometimes it is more prominent during the either rainy season, and in summer you will find it is less effective. Now removal of the casing, short casing, again it is a problem, particularly for the large diameter pipeline, because what is happening once you lay the pipeline is like 36 in diameter or maybe 42 inch diameter and all that, then the casing size is further bigger. Then when road crossing is taking place, or particularly the rail, then you will finding during the just putting their carrier inside the casing, that time also it will damage the insulators, and then pipeline gets short during the construction time itself. So removal is a problem. So first thing is that we should avoid the casing as far as possible. But in Indian scenario, that railway is not giving the permission to cross their railway lines without the casing. So there it will become very, very important. But otherwise for the road, it should be avoided as far as possible. Now the city gas distribution company, as you know, it is basically increasing day by day. Now as on date, near about the 40 cities has already been covered by different companies. There are near about 23 companies in India who are operating in different cities. And now the government is telling that within next 5 years they try to want to cover almost 200 cities to supply the compressed natural gas as well as to provide the domestic connections. So naturally this business activities or infrastructure will increase, and total CGD means length of the pipeline is really very large. As I am giving the example of Delhi, Indraprasth Gas Limited is operating near about 10,000 kilometer pipeline. So out of that, steel is only say maybe 700 kilometer, but total length is really very high. And this is MDV pipe, so more susceptible for the third party damage. But only advantage is that you are operating your pipeline but at a lower pressure. So once the pipeline, the gas is coming to your city gas station, you are maintaining about 30 kg or 35 kg and all that. You operate your compressors, CNG stations, where the suction pressure is near about 20 bars and the discharge pressure 250 bars for filling the vehicles. But once you want to supply the gas to the colonies, okay, the societies and all that, you reduce the pressure from first 20 bar to 4 bar, and once you go to individual house, you go to the 21 millibar. So really pressure is less, but possibility of damage is very high. So on an average, we are finding 2 damages per day in Delhi. Only thing it can be rectified fast because it is a MDB pipeline. So you can squeeze the pipeline, you can shut off that area, and then maybe you can replace that section very fast. That is only the advantage, but otherwise the safety hazard remains there. So the government again has to make some sort of a policy in case somebody is digging. At least he should give the call of the to all the utility companies that okay, I am going to dig whether your pipeline or cable, whether electrical or it is a your telephone wire or maybe a water pipeline is there or not. In case they become unsure, only then the digging should be carried out. So that sort of a thing will come now. GAIL has also taken up with the ministry. Most probably something will be coming up. Then here main problem is the no pipeline corridor, only the laying permission, and it is again very difficult to lay the pipeline in the city. Deep well anode bed due to the scarcity of the land, because you have the pipeline, you have the road like ring road and all that. Most of the time you will find a lot of traffic and all that. Now pipeline you are laying. Now you say that I will go to anode bed which is near about 100 meters perpendicular to the pipeline. The land will not, that space will not be available. So you normally go the vertically. That is the problem. Then the metallic pipeline runs parallel to the gas pipeline. Other pipelines are also there. So once you try to maintain the potential of pipeline, your most of the current is picked up by the other pipelines which are really not coated. So when you go the water pipeline, drains pipeline, or maybe other, that is picking up your. So normally current consumption is very high. Then the power cable crossing or the parallel to the pipeline. Say lot of pipeline now at the cables, particularly at high pressure, almost 220 volt kV, 220 kV DC cables has been laid in Delhi, and once it is crossing to your pipeline or running parallel to the pipeline, it is causing again the interference. So you have to take the remedial measures. The metro railway is coming. Then third party damage I discussed is very common. So here just to show you in Delhi itself, you have a 220 kV power cable belonging to the Delhi Transco, and this pipeline are crossing. So we are taking this remedial measure whatever is possible. Though a lot of agencies are there to regulate, to monitor all these things, the PASO is the one. As you know, after this accident of KG Basin, the PASO has come into the picture and then say that when you are laying the pipeline, you have to take the approval from them. This is, then PNGRB is also there. OISD is again carrying out particularly for pipeline more than 100 kilometer length. it is supposed to be audited every 3 years. Then people are going for ISO standards, various standards, whether it is 14,000, 18,000, 9,000, and they also carried out interdepartmental audit also. But in spite of all these audits and all that, accidents are taking place, damages are taking place. So naturally, I mean, we have to really think of whether, I mean, carrying out a lot of audit can solve the problem. This cannot be solved by carrying out audit till the person who is really working on that pipeline at the time of construction, in case really not a good job has been done during the construction, commissioning stage, designing stage. I mean, nothing can be compensated by audit. Audit only comes once I have completed my job. Then the audit comes into the picture. They can only highlight it, but there are some things which cannot be really changed. Say I have the pipeline, maybe HVJ pipeline. HVJ pipeline is operating since last 25 years. It is operating at 91 bar pressure. Now what is happening is basically that time when we laid the pipeline and right now, actually population density is changing. Though the lot of extra margins, the cushion has been taking the thickness while deciding the thickness of the pipeline, but even then, I mean, nobody has thought out after 15 years what will happen, 25 years will happen, and it is not also not possible to again reduce the I mean, pressure of the pipeline, because pipeline that HVJ pipeline is operating almost at 100% load. So there has to be some sort of a method. When I say that population density, in case it has increased, what are the other remedial measures? Whether I just by increasing the surveillance on the pipeline, can it be improved? Whether can I go for the maybe a concrete layer of the pipeline? Can I put the walls I mean along the pipe, maybe for some distance, 500 meter, 200 meters, so that I mean sort of ultimately once damage take place on the pipeline, it should not really affect the population density surrounding the pipeline. Those sort of things has to be now thought of, which is this should be as per the I mean practices to be adopted. Basically, standard doesn't allow it, but again in some countries this is being followed. So here also it is to be followed. So skill development is one of the challenging things in India. Particularly, you might be seeing that earlier in all the companies, I am not talking specific in the company, whether you talk particularly the oil companies, say anybody can be put in any of the department. So when you talk about the, like you have the corrosion control department, so there is in most of the companies there is no corrosion control department. Anybody, whether you talk about civil engineer, chemical engineer, mechanical engineer, electrical engineer, anybody will be just transferred every 3 years, and he will come, he will try to understand what is going on, what is the cathode production, how it is being maintained, what is PSP, what is 0.85, what is negative, what is positive. Once he try to learn within first 1 year, 2 years, he will get transferred. Then second person will go and on. So there is a need to develop the pool of manpower who really know about the corrosion, who should know really about the coating, who should know about the testing, who should know about the audit, okay, who should know about the cathode production, who should know about the survey and all that. Only then things can be implemented properly. So there is a need. So NACE has also now lot of, because accident has taken place, now companies are much more aware, and now they are thinking that okay, we should be go for sending our person for certified courses. Earlier, person go for the 1-day course and say I have become the CP expert. So that should not be there. The people's something they learn in the field by carrying out their job. Sometimes they go for the training program, maybe 1 week or 10 days and all that, they learn something. So, but once they continue in that department, only then become the perfect. So here my only request is with all the organizations is basically they should give the much more importance to the training, and the proper certified course should be carried out by whatever the agency. In Arab countries and all that, if you go there, they will not allow anybody in case you are not having a certified course, particularly NACE course or maybe a SME course and all that, whatever they recognized by that country. But that certified course should be there. At least they know you know the minimum thing. So in India also now it is taking place, lot of now courses are taking place, particularly in GTA, in GAIL. Say now CPA, this coating inspector course has been carried out. CP course first time it started in India, though they charge very high, almost more than 1 lakh rupees. There is basically 5-day course, but it is worth, because what you learn is really useful. They normally carried out a lot of hands-on training and good material, Even the person who are having maybe 20-year experience, once they are going, they are also learning something new. And last time they have carried out CP3 course, which was basically first time in India. And I understand 20 people who are having the 20 years experience, they have gone there, and only out of the 20, only 3 people have passed. All 17 has failed. And that is basically those failed, they are having a sort of a contractor, they are already working in the field for 20 years, they are designing a CP for this and all that. This has happened in spite of all these things. So you can understand what is the our level. So we may be claiming that I am the CP expert, he is this, he is that, but really when it is coming to the field, things are really different. One example I can give you, basically some organization in some place, I don't want to mention the name, say there are 5-kilometer pipeline, and then once pipeline was installed and commissioned, CP system was commissioned, there was a wrong connection. The anode was being made cathode was being anode, basically positive and negative was changed, and for 5 years people were just taking the reading. So per person what he will do, he will have maybe a multimeter in his hand, he will just put between the half cell and the pipeline, and they will try to say, okay, it is showing minus, it will say the 0.9. Now 0.9 is coming positive, what he will say is just will change the lead, he will say minus 0.9. Well, that is okay. So he do not know really where the plus will be there, where the negative will be there. Everybody see the 0.85, it should be more than 0.85. Whether it is minus or it is a positive, I mean nobody is worried. Only by changing the 2 leads, you are getting satisfied. Okay, it is minus. So they basically the things has been made different. The pipeline we should have run maybe for 30-40 years. Was suppose it was replaced within 5-6 years. So my only request is the person should have a field experience. That is more important, not only the 30 year. So the measures which can take, basically the inline inspection of all the piggable pipeline, wherever it is piggable. In case it is not piggable, let us make them piggable wherever it is possible. In case it is not piggable, let us go for the direct assessment system. We should make the SOPs. We should have a eminent expert, corrosion expert, international expert. In case in India it is available, lot of people are available. In case it is not, let us have international knowledge we should bring to India, so that we should take the advantage of it. And then wherever casing sort are taking place, I mean we should remove it, we should develop the skilled manpower. Then common issues, as I discussed already, it is basically common ROU problem is the rising problem in India, because a lot of new pipelines are coming. It is in more, they are the ROUs where 3-4 pipelines are going in the same ROU, different companies. Say we have the pipeline, Jamnagar Loni pipeline, again another IOC pipeline, then another GAIL pipeline, then another IOC pipeline, this is coming. So naturally you have the multiple of anode beds, and then sometime one pipeline is coal tar coated, another 3-layer P coated. I mean one company may not be allowing the bonding with another pipeline. So this sort of a challenging problem are there, so it is to be resolved. No clearance from the pipeline operator by the power utility companies. Say one pipeline is laid, another, at least one company asks from another company. But once the high transmission pipeline, these power lines are being laid, they normally don't ask from the pipeline company. There should be a rule that they should ask, because ultimately it is causing a lot of problem to the existing pipelines. Then casing sort is a problem, use of untrained manpower, I had discussed already. Not sufficient national codes. Most of the time we refer to the NACE code, or we go the SME code, the Canadian code, this European code and all that. The Indian code we should start following up, and we should upgrade the Indian code. Wherever it is not there, we should make the new Indian codes. And the government should also make some rules and regulation. So skilled manpower is one, certified manpower to be used for the pipeline, and particularly the corrosion engineers, the cathode protection specialists, the coating inspector, that sort of a course should be done in India, so that at least the quality can be maintained. With this, this is the summary what I have already discussed, that pipeline infrastructure to increase with the increase of the oil and gas. Once the energy mix is increasing, definitely whatever the gas consumption today is basically near about 8 to 9% of the total energy mix in India, it will increase to 24%, 23% as is happening world over. Then pipeline to remain the cheapest and safest mode, so naturally people will go for this, for all, at least petroleum product also, and slowly nowadays a lot of water pipelines are coming. Then pipeline integrity management should be given the topmost priority. Internal, external corrosion monitoring is very important. Wherever the interference, to take measures to avoid the current interference on the pipeline. Then direct assessment is very important when you are not able to go for the inline inspection tool and using the trained manpower. Thank you very much.
It is customary that the keynote address and the invited speaker